This question belongs to variable loading. This question belongs to design of machine elements from the topic variable loading. So here is the question: the endurance strength of the beam subjected to pure bending decreases with. So here endurance strength as per the Moore experiment, or if it is in case if it is subjected to reverse bendings, they have obtained that to be as 0.5 times of sigma ut. Okay, this is a statistical, this is the value obtained by the experimentation. So now again here the endurance strength, this is the value obtained without considering the quality of surface or size of the specimen or the kind of loading or environmental conditions were not considered here. So here now when you are calculating the, when you are checking the corrected endurance strength, okay, there will be the factors, there will be factors K surface, comma K size, comma K load factor, and K temperature and reliability factors will be also considered here. Okay, so our discussion is with reference to surface and size. So now the endurance strength with the increase in surface roughness, the K value with the increase in surface roughness, the K value or K surface drops. When the K surface drops, it will drop sigma E value. Similarly, due to size factor, when the size factor increases, the size factor or the factor due to size decreases, which in short decreases the endurance strength also. Okay, so here with the endurance strength, the endurance strength of the beam will be decreasing due to increase in the surface roughness and due to increase in the size. That is the option C. This is the end of the answer. This question belongs to the topic design of machine elements from the topic brakes. A short shoe external drum brake is shown in figure. The diameter of brake drum is 500 mm. The dimensions A equal to 1000 mm, B equal to 500 mm, and C equal to 200 mm. The coefficient of friction between the drum and the shoe is 0.35. The force applied on the lever F equal to 100 newtons as shown in figure. The drum is rotating in anti-clockwise. The braking torque on the drum is dash Newton meters. Okay, so here is the value, here is the braking torque given to you. Here is the dimensions of brake, that is A equal to 1000 mm, B equal to 500 mm, C equal to 200 mm, and mu is equals to 0.35, and F is equals to 100 newtons. This is the applied force given to you. This is the given data. Now coming to the brake diagram. Okay, here is the shoe given to you. Okay, this is the drum. Okay, I am isolating this. It is rotating in anti-clockwise direction. So the friction force will be acting opposite to that. That is equal to mu times of Rn. Friction force will be acting opposite to that. That is mu times of Rn. And another force that is, there will be a contact. There will be a normal reaction, that is Rn. Similarly for the shoe if I draw, it will be Rn will be pointed upwards. When you are reversing Rn, you have to reverse the mu Rn. These two are the reactive forces, that is mu Rn to this side also. Okay, and this is here there is a force F which is present. So he is asking you to calculate the braking torque. The braking torque is equal to how much he is asking you to calculate. So now here this dimension is A given, this dimension is A, and here if this is B dimension, this dimension is B, and similarly this is C. Okay, now taking the moments about the hinge O, okay, So moments about the hinge O, that is about O, F will be in anti-clockwise. About O, F will be in anti-clockwise, that is F into A, and Rn will be in clockwise direction. Rn will be in clockwise direction. This is minus, this is Rn into B, and with respect to O, mu Rn will be in anti-clockwise direction. Mu Rn, just extend this line and try to rotate this line in this direction. So it will be in anti-clockwise direction. So it will be mu times of Rn into C equal to 0. Now if you substitute here, this will be Rn into B is equals to Rn into B, that is B is equal to 500. So Rn if I pull out, this will be 500, B will be 500, mu into C, mu is 0.35 and C is 200, minus 0.35 into 200, this will be Rn, bracket close, and this is equal to F is equals to 100 Newton, F is equals to 100 Newton, and the length of distance of the force from the hinge, to hinge is 1000. Okay, upon solving this you will get Rn equal to Upon solving you get Rn equal to 232.5 newtons. So now your braking torque will be equal to Tb is equals to mu times of Rn into radius. So mu is equals to 0.35 into 232.5 into radius of the drum. Diameter is given as 500 mm. So this will be 0.5 by 2. So upon solving or multiplying this, you will get the answer as 220.35 Newton meters of braking torque. Okay, this is the end of the answer.